So thanks for having me, guys. Today our demonstration will be on next generation of design with NX. I'll be your presenter, Bryan Fischer. I'm with Prolim out of Cincinnati office. Prolim is a platinum partner with Siemens. Brief history of myself. I've been with Prolim for a little over 2.5 years. Prior to Prolim, I was in the aircraft industry for 15 plus years as a designer. And then I was in the medical industry for 5 plus years as a designer. On our agenda today, we'll be looking over some industry challenges. We'll go over some business impacts. We'll look at a new way forward with Siemens. And the majority of our presentation and demo will be on next generation design with NX. We'll wrap it up with some customer success stories and how removing barriers to innovation. Here we see some business trends. Digitalization is transforming the innovation. When I look at this, I look at the generative design. Generative design's been around for a while. We've been able to create those models, but they were more of an academic exercise. Now with additive manufacturing, for example, we are able to reduce those models now, whereas in the past, with traditional manufacturing, we may not have been able to do that. So with advancements in additive manufacturing, we're able to do this in many different materials. Intelligent models. Everything speaks with each other now. All we have to do is look at our cell phone, for example. It can talk to our car, our refrigerator, even our TV. And along with the intelligent models, here we have advanced robotics. So everything's talking with each other. And this can all be done within the cloud. The cloud is an area where we all operate now. We stream music. We stream movies. And we can utilize that to be able to collaborate with each other easily. So if we look at this next slide, we show some of these innovations. We see virtual reality, artificial intelligence, IoT, Internet of Things, and 5G. When I look at this, I look at the virtual reality. Virtual reality in the past was more for gaming and entertainment. However, myself, I've used this in the design industry, NX virtual reality. When I was in the robotics, in the medical industry, I used this to be able to go in and put ourselves virtually into a surgical room, and we could see where equipment would be, where individuals would be, and that helped us with our design. So how does this impact the business? Well, if companies don't evolve, they risk becoming obsolete. When I look at this statement, I kind of think of, when the blacksmith was around when the vehicle first came. Those individuals that were blacksmiths that didn't evolve into mechanics more than likely lost their position and lost a lot of customers. So if we look at these possibilities, what if you could innovate faster? What if you could predict product performance sooner? What if you could increase your manufacturing flexibility or grow expertise? Well, our solution to this at Siemens is next generation design. We can help you rethink your product. We can help you deliver these products right to the market the first time. And we can drive your innovation all the way from the concept through manufacturing. If we look a little closer at our platform here, you can see we have electronics, mechanical, manufacturing, and so on. For today's presentation, we're going to be focused on the mechanical design with NX CAD. For simulation, we're going to be using SImCenter 3D. And for manufacturing, we're going to be using NX CAM. And we'll be doing all this and collaborating all of our data within SImCenter. And this will all be done within one interface. Additionally, we're going to be showcasing our digital twin. NX and SImCenter enables us to design, simulate, and verify that our digital twin product. Additionally, we'll be going in NX CAM and showing the digital twin. And we'll be collaborating all this again in SImCenter. If we look at our wheel here, today we'll be focusing on product design, model-based definition, knowledge reuse, and design validation. However, we do have other areas that we are able to help your company as your company grows. Model-based definition is an area that I like to look at. It's product information, product PMI we call it. And this is an area that allows you to put data on a 3D model. And this can be downstream to other areas such as CMM or even to another product of Siemens called Vismaka VSA. That allows us to go in there and do complex stack-ups. For today's presentation, we're going to be going in a lateral movement here. However, we could be doing this in concurrent engineering. The first step we're going to do is concept. We're going to redesign a product, which you see here is our saw, and we're asked to redesign the outside case a little bit and also take this design that was a corded design and make it a battery-operated design. From there, once we have our concept, we're going to go into detail. We're going to make a right-hand part. We're going to shell this part. We're going to add ribs. Then we'll move on to documentation. We'll show some PMI on a particular component, and then we will go and make that component and take it into a 2D drawing. From there, that information will be put into a 3D PDF. We'll then move on to validation. We'll do some critical validation checks, model checks, and then we'll move into simulation. We'll show some SImCenter and some FEA results, and we'll make a change from those FEA results. And we'll wrap it up by showing it in manufacturing and how those results can be carried on to the manufacturing side. So let's go ahead and start with our concept here. We're going to work in the context of an assembly. We're going to use an artistic image as a reference, and we're going to morph a primitive shape and surface into a new case design. So let's go ahead and jump into NX. Here you see our design here, and this is our current model. And I'm going to cut a section in here. One of the other things we're asked to do is to make sure all these components fit within our new design. Additionally, we were given a raster image. This image here allows me to utilize it and help me create my concept. And we're going to be using NX Realized Shape. NX Realized Shape is a subdivision model. It allows me to come in here and take these primitive shapes and quickly stretch and tug on these and kind of think of it like clay almost. I'm able to come in there and stretch these and quickly get a concept. This will allow me to get this to our marketing team quicker. And when I'm working in something like this and we have an image in the background, I like to go in and actually edit this and make it translucent so we can see that in the background. Additionally, what I like to do, because this is a model that we want to be symmetric, I'm going to start some symmetric modeling. And to add more handles to grab, I'm going to go in and create this and get us some more handles. Next, we're going to go in and we're going to keep on going in and selecting these handles and quickly morphing this into a concept. I can transform by box them all at once. I can do points. I can do portions of a section. It all depends on what we need here. And you can see we're quickly going in and morphing this into a design that we're going to be able to utilize and quickly even make a rapid prototype maybe. Maybe we'll use some added to manufacturing and get us a rapid prototype here and be able to hand it off to our design team or our manufacturing team. And once we have that finished, let's go ahead and skip a little bit forward here and show how this can be used with traditional modeling tools also. Go to our midpoint here, and you see there's our model that we currently just created. And then we have a handle here. We're going to concentrate on the handle here this time, just because it needs to be put into a solid model. Right now it's a sheet body, but that's not a problem. We can go in and not have to leave NX and work in our surfacing tools now. So let's go ahead and sew this together real quick. And once I sew it together, I am still going to use that image in the background to help us shape this. I can pick individual edges, or I can box them as you've seen that I did on the other one there. And you can quickly come in and morph this model and create it into a solid. So you don't need to have multiple different products. We're staying in one interface and doing all of this. Now I can come in and just continue to transform this cage just like we did prior on the other model. And you can see it's real simple. It's not a complex tool to use. I can quickly come in and morph this and get multiple concepts. Additionally, the nice thing about this is I'm going to be able to come in here next and unite this and use some traditional modeling tools. So I don't have to have special tools to do this. Now that I have that, let's go ahead and hide our image because we don't need to see that image anymore. We already had it. And I'm going to go in and draw a real quick construction line here. And I'm going to fill these areas in where we can come in and use our surfacing tools. So right here we have some surfacing tools. And we want to come in and we want to fill this surface. This will help us quickly make this a solid model. And let's go ahead and sew it together. And now we have our solid. So now I'm going to come in and use some traditional models such as unite. Maybe I want to do some blends. And once we have this done, like I stated, we could send this off and get a quick rapid prototype done, especially with that to manufacturing now. And now we have our solid there. So we have a quick concept that we were able to go in and create. Next, we're going to go on to detail, but first I want to show you that we worked in the context of the assembly. We used our artistic image as a reference. We morphed the primitive shape and surface into new case design. We did all this within one interface. Therefore, we were able to innovate quickly. We didn't have to have multiple different softwares. Therefore, we didn't have to go and actually train individuals on multiple softwares. And this helped us eliminate costs and innovate faster. Next, let's look at the detail portion here. In the detail portion here, we're going to link a concept geometry to detail mechanical design. We're going to reuse standard geometry from a library. I'm going to reuse some sketches that we have that's going to drive our ribs that we're going to create in here. Then we're going to do an adaptive design with synchronous modeling. Synchronous modeling is a nice tool that I can use not only in traditional modeling, but I could use it for imported geometry. A lot of times when you get imported geometry, you don't have a tree, model tree, but in this case, what it allows you to do, you can move faces, you can resize holes, and you can start to use this, and it creates a tree for you that you can always come back and edit. Now that we're back in NX, you can see that we have here. And in the assembly tree, you can see this is our top level that we're going to be using as our concept. We're going to take this and make it a right-hand part, but we're going to link it back to the original concept. We'll do that within NX by using Wave Geometry Linker. This allows me to link back to the original model, the concept, and you could have concurrent engineering going on. You could have one individual that may be able to go in and make some slight changes to the concept while another individual is going in here and making this a right-hand part. Let's go ahead and make some trims real quick. And you'll see we're quickly able to come in here and make this a right-hand part. We're going to take this now and we're going to hollow it out. But before we do that, what I like to do is when I'm working with a wave geometry, I often come in and edit this and make it a different color so we know and be able to tell the differences between the concept and the original model. So here you can see we now have our linked body. And let's go ahead and make a shell out of this. And the next thing I want to do is I'm going to come to my reuse library. Within our reuse library, I've already gone in here and I put some sketches. This can be used to help go in and actually standardize some of your sketches or your best practices. In this case, I'm going to use this for these curves here to go ahead and make some ribs. I could go ahead and choose a whole sketch, but in this case, I only need a few of these. I don't need all of them, so I'm just going to come in and choose these. Additionally, I'm going to come in and I'm going to put a cap on this. Let's say 2. And we'll put some draft to it also. Now I have my ribs. Now, as I'm looking at this though, I notice that there's some information here, some ribs that I need to move. I need to make room for the battery. So I'm going to go ahead and move these ribs by using synchronous modeling. As I stated earlier, these commands can be used on traditional models or non-traditional models. So if you have a Parasolid or if you have a model that came from another CAD system, you can go in and actually utilize these commands that I'm using right now. Now looking at this, I may have to go in and rotate this to get us a little bit more support also. So we'll go ahead and rotate this rib. About 35 degrees should do. And you'll notice I have to do the other side also. Once we have this done, I'm looking at this and I notice there's an area that still has a rib that I'm going to have to go in and delete some of that face. And we'll do that with synchronous also. So let's go ahead and finish this one out first. And this area right here, I want to go ahead and remove that portion of the rib. So we're going to come in and delete this. And now we have ourselves a nice concept. Now I want to show how this works with the digital twin. We're going to come in and do an analysis on this one rib. And I'm just going to go and do a length here. And you can see currently we have a 51.4681 rib. We'll go ahead and put this side by side so you can see it. Now you can see here's our original concept and there's a shell that we just made. In this case, I want to come in and I want to edit this portion of it right here. We're going to edit this one section. So let's say we were working on this and somebody came in and they noticed that this handle portion of it needs to be changed. So if we come in, I can quickly change that portion of the body or the handle. Let's go ahead and change the handle real quick. And when I change the handle, what I'm going to do is we're going to make it a little bit larger or a little bit smaller. So we're going to take this and we'll make it a little bit larger, let's say. And I'm going to say OK and finish this out. And we'll notice that our length changes. It changes on this side and this side. This shows you how the digital twin comes into play and how it can be used. So, with this, we were able to show you and link the geometry to a detailed mechanical design. We reuse standard geometry from our library to create our ribs. And we adapt the design with synchronous modeling. This helps us reduce costs, innovate faster, improve our productivity because we can trust that our concept and our detailed models are coming from the same geometry. It's trusted geometry. In our next portion here, we're going to move on to the documentation. We're going to look at model-based definition. We're going to create PMI on a 3D model. We're going to automatically document that in a 2D design. And then we're going to publish technical data package. And with that data package, we're going to collaborate with our suppliers. So let's go ahead and jump back into NX again and take a look at that. I'm going to go ahead and open up this particular driver component. And PMI is used within our model views in NX. So here you can see we have a left and we have a datum A and we have some of our diameters in there. And then we have a section. Now looking at this section, I see there's a couple areas that need a dimension, GD&T, and so on. So I'm going to go in and turn on my PMI, and I'm going to go and dimension this real quick. Dimensioning is real easy in NX. And if you can use this in the PMI, you can do it in drafting, you can do it in sketching. Here I'm going to go ahead and add me a tolerance. And then we're going to go over and add a datum feature, datum B. And let's go and add some GD&T. And here you see we have our GD&T here. We have perpendicularity and so on. I'm going to do perpendicularity, 5 thou, and the datum A. Now there will be times where you're working with a customer or even somebody within your own company and they're like, you know, I need a 2D print for, you know, this. I don't have PMI, I don't have NX or whatever. So we come in, we can quickly come in and create a drawing for them. Now the first thing that's going to occur here, it's going to populate a title block. Now this title block here is an out-of-the-box title block. However, this can be customized for each company, including your own company. You can have your own border. You can customize this to be whatever you want it to be when you go to populate this title block. Next, it's going to put us go in and put these base views. And now I'm going to go in and I'm going to add my section view. Let's say I wanted to put my section view in. I don't want to have to go and recreate all those dimensions. So the nice thing about PMI is I can come in here, inherit this information, and quickly put it in to my drawing. Now, much like I was showing on the other one here, these are connected. So if I come in right now and put these side by side, I could have an individual working on this drawing while another individual is working on this particular component. Maybe they have to make a small design change. They could be making that design change while another individual's in here, maybe adding charts, graphs, setting up their section views, and so on. So here we went in and we noticed that this 11.6 was a little large. We needed to actually come in and make it 11.5 after we did some stack ups. We made that change, and the individual that's working on this drawing at this time will get an update, and they update their view, and you'll notice that the 11.5 changes there at the same time that this changes. Now, when I was a designer, the way I utilized PMI, and I utilized this to help train my design detailers. I'd have my detailer working on the model here, the detail, while I'm working on the design. I'd set up my datums and GD&T, and then when they plop those in, they would bring in that PMI, and they would know those particular faces were important, and that's what they would dimension off of. Now let's go look at the technical data package within here. So within the technical data package, let me get to my correct part here. In our PMI, we're able to collaborate with our customers. We can actually come in and publish different 3D PDFs. So here you see out of the box, I'm going to go and choose one of these. There's a lot of them to choose from. So you have different ones that you can choose from, and depends on what you like. I also have where I can select my views or say all views. In this case, I'm just going to say all views. In this particular one, I have some text that allows me to put into it. I'm going to go ahead and put this information, and this will put it directly into my 3D PDF. I can also come in and add attachments. In this case, I'm going to go in and find a JT file, which is a lightweight model, and I'm going to attach that to it. Let's go ahead and create this now. It'll take a few seconds here to run through it and publish it. And once it comes up, we will have ourselves a 3D PDF that we can collaborate with our customers or even individuals within our own company. So here you see our right, our left, and you can see it is a 3D PDF. Additionally, you can see the information that I put in here. There's another area where you can put comments. And I can send that off to our customer or individuals within our own company. Now you've seen how we can create the PMI, how we were able to automatically document that into a 2D design, how we were able to publish a technical data package, and how we're able to collaborate with our suppliers because of this. This reduces costs because this PMI can be used downstream, as I mentioned earlier, how I used it for stack-ups. It can also be used for a CMM inspection. And if you use a Step 242, you can actually transform this data out and somebody else within another CAD software can bring in your information and it will still be PMI that's attached to that particular part. In this next portion, we're going to look at validation. We're going to do a visual report of system info and weight on a 3D product. We're going to perform a critical design check, and we're going to run clearance analysis. All right, we're going to jump back into NX for this. And I'm going to use it on the finished product. So let me go ahead and put this to our finished product. And within here, we have our visual reporting. There are several reports that we can go in and actually utilize and create. In this case, I've already done a couple of them here. For example, I did one by component group. Once I activate that, you can see it color codes it. And the nice thing about this toolbar here on the left-hand side, it can actually be docked on a second station, a second monitor, so you could actually free up some space there and you will be able to expand this and really look at it. Additionally, up here, we can go in, and if I expand this a little bit, you can see we can filter this way. And we have a visual reporting up here that we can look at. If we explore the data here, you'll see that it will make translucent of the other parts and highlight these parts that belong to that group. If we jump in here, we can come in and actually do another one here. I did one for weight. And you'll see here that we have these little tags, and it color codes it again. And we have the same ability that we had with the other one. And if you look at these tags, I can show info on those. The info will tell you information on here. If you wanted to edit this, it's very easy to edit it. So for example here, let's go ahead and say, maybe we want to look at this, and that's now a high priority, not a low priority. We have the ability to come in there and change that to medium or high, and now we have that information. If I close out of this one, we have what we call checkmate. Now this is another area that I used a lot when I was a design manager. When I was a design manager, I had a checklist that I wanted my designers to go through and use. That way, if they handed off the drawing or if they were going in to maybe issue it or to design, you could come in there and run these checks. So maybe we have, let's say in drafting, we want to check up the date. Maybe in assemblies, we want to go and do a clearance analysis. And in modeling, maybe on a sketch, we want to make sure everything's fully constrained. We execute this check, and right away we can look over here and we can tell that our clearance analysis has not been ran. Let's jump into the clearance analysis here and run that real quick. So as we perform this analysis, it's going to go in and see if there's any interferences. Now, is that the design intent? There may be some times where you want that to be the design intent. Maybe you want to heat and cool stuff together. Maybe you're snapping pieces together. Maybe you got a dowel pin and you're trying to do a press fit. What this does, it allows us to go in there and look at these interferences. We can see if the distance is correct for the interference. Is there too much interference? Not enough interference. Additionally, we have a status line here that will allow us to go in and tell if we've looked at that, if it's been resolved or not. So we're about there. We're at 98% right now. We see we have 195 interferences. Let's go ahead and just look at one particular one. And we can study that interference. And we can come in and calculate it. And we see that we have this much interference right here. If we determine that that interference is fine, we can come in here and actually say resolve. Now, once I run this and rerun Checkmate, Checkmate will recognize that we ran that, and we are now able to hand this off, issue the model, or whatever we need to do. So, as you see, we were able to do a visual report in a system on info and weight on data on a 3D product. We were able to perform critical design checks. We were able to run a clearance analysis. This helps us reduce costs because we're catching mistakes earlier in the design cycle. We're able to validate these before releasing it to production or handing it off to another individual. In our next portion, we're going to look at simulation. We're going to use the digital twin to drive a simulation. We're going to gain insight from our CAE results. And then we're going to make an associate design change. Let's go ahead and jump back in NX now and take a look at this. So this simulation is done in SImCenter, which is embedded within NX. We do not have to leave this product. We are staying within NX, and we're going to go and actually look at some simulations. The whole purpose of this is to show the digital twin. It's not to show you how to set up simulation. I've already set up a lot of these results. We're going to look at these results, and we're going to make a determination from those results about a model change. So here we have it open now. And as you can see right here, these are our loads that we have. And we want to go in and look at some of these. So I'm going to go and look at some of these results. The first result we're going to look at is displacement. Now I do want to go in and change my deformation to 1. 10 is a little extreme. And we're going to focus on this area right here. That's a rib area that we need to change. If we look at our stress, we can see that same area. Let's go ahead and make that change. Now that change could be made by either the designer or could be made by the individual that's running these tests. Go ahead and make a change. We're making it a little extreme so we can really see these changes. And once again, I want to point out I did not have to export information. I was able to quickly go in and use my synchronous tools here to make this change. So now we're going to go in, and this is going to go and remesh this. It's looking at the information in the background because we have set up tests. And we won't have to rerun these tests. It's going to recognize this change. And once it comes in here, we're going to finish this, and I'm going to remesh my model, and I will show that these loads are recognized. So here you can see we have these area that we recognize needs updated. I'm going to go ahead and update it. And it's going to tell us right here, actually, that's processing through this, regenerating, and remeshing apart. This saves us a lot of time, though, because we're not having to go in and search for another, model and import it into a different software program. So here we have our results. And as you can see right here, we kept our loads. Using our digital twin, we were able to drive our simulation. We stayed within the same software, same interface. We were able to gain insight from CAE results, and we were able to make an associated design change. Once again, because we're not searching around for, another file and trying to import it and export and everything, we're able to catch mistakes sooner. We're able to innovate faster. We're able to improve our quality. For this next portion, we're going to get into the manufacturing. We're going to use a digital twin from our tool to drive machining operations. We're going to review some toolpaths. And then we're going to make associated design changes based upon the FEA results that we just seen. Let's go ahead and jump back into NX. And for this particular one, I do have to change my load options real quick. And let's go ahead and open up our model here. Now, much like the simulation, the purpose of this is not to show you how to write the toolpaths, but to show you how the digital twin, when you make a change, goes downstream. So to start off, let's go ahead. We got a fixture here. We have our cover, and then we have our machine. Let's go ahead and hide some of this. And we're going to focus on this particular rib right here. Now you see we already have toolpaths in here, and we have several of them already written. And we're going to go in and make this my work part, and we're going to make a quick design change based upon the results that we had from our FEA results. I've already gone in and made some of these changes, and I'm going to unsuppress them here. And you'll see that our rib area that we worked in is now a lot larger. And what we want to do is we want to come in now and come in our part here, the top of the machining. And you'll see that I can regenerate this toolpath pretty quickly. I don't have to go and pick new faces. I don't have to go and export and import material. All I had to do was come in and regenerate my toolpath. So you can see here how that could reduce cost and cycle time. So we reused our digital twin from our tool into driver machining operations. We were able to review our toolpaths, and then we made an associated design change based upon those FEA results. In this next portion of it, we're going to be looking into SImCenter. Inside here, we're going to quickly search for some data. We're going to initiate a design change process from that data, and we're going to review non-CAD data. So here you see I'm doing a search for the parts that I own. I look at my results here, and I see that there's a concordless competitor here. You see we got JPEGs in here, and then we could also come in there and look at some particular components. Here we're going to look at a where used, attachments. You can look at the history of it. We can look at our performed design changes here. When we go in there, we're going to look at the attached items. And you can see here it's showing the results here pretty quickly. And you will see here in a second we can use our Word document. Inside that Word document, it lets me know what those design changes are. I can get this information to an individual real quick. And from here, once we have these design change, we're going to go in and find ourselves a JPEG. And this JPEG, much like what we used earlier when we were doing our design concept, will be used within NX. So we're going to go in, actually bring this into NX. And we're in NX at this time, and we could quickly use that image. Now, the nice thing about SImCenter is it helps you collaborate within your own network. You can set up groups. You can set up roles. You can determine if an individual has the right to make these changes or just view them. So you've seen we quickly searched for some data. We initiated a design change process and we reviewed non-CAD data. And the other thing about SImCenter is it's trustworthy information. You're not having to go look on other servers or other folders. When there's a Rev 1, there's only one Rev 1. There's not multiple copies of that particular product or design or file. So this avoids costly mistakes. If we look at NX now, NX has had success in many industries. I myself have been involved with the aerospace, automotive, marine, medical, energy, and I've done this all in NX. So let's look at some customer success stories now. Piper. Piper is in the aerospace industry. They use the digital twin to help reduce costs. They use SImCenter and a digital thread to track hundreds of parts and know exactly where they are in each aircraft. This helped increase fuel payload by 35%. They were also able to improve the flying range of their M600 by 40% and increase useful load capacity by 29%. I would say that's a pretty good success story. If we look at Hendrix Motorsports, now with the pandemic, this really made a huge impact on Hendrix Motorsports. They were able to use simulation to evaluate more option and optimize design. Most of the teams were not able to go and practice on the tracks last year. Therefore, simulation played a huge role in helping Hendrix Motorsports have an advantage on their competitors. They had 36 consecutive weeks with new product. Now, how did it help break down the barriers of innovation? Well, as I stated before, we only really looked in the mechanical side here today. But let's say your company went in and you guys want a contract with electrical. We can help support that. So we can help you grow. Additionally, with our new concurrent engineering and what we call our continuous release, we're able to get products to you faster and able to get you new tools faster. We have a monthly update that we send out to you. And every 6 months, we send out a bigger update. This gets things to you quicker. Additionally, NX is a very well-known product that is very trustworthy. I have opened models up from 20 years ago and still been able to go in there and update those models and keep on working on those models. Whereas some of our other competitors, you may lose that model tree. Whereas with us, you do not. So we're able to help you get to the market right the first time. So that concludes our demonstration today. At this time, I'm going to open it up for any questions or comments.